the most iconic planet in the solar system, needs little introduction. A planet surrounded by some of the most stunning vistas. But what do we really know about the stunning ringed planet Saturn? Saturn has been known since the ancient times. It's a little yellowish star in the night sky, and it was named after the Roman god of time, harvest, and agriculture, who was also the father of Jupiter, although how little they knew about the stunning world that it was. Saturn is of course the sixth planet from the Sun. It orbits 1.4 billion kilometers from the Sun, which is about 10 times further from the Sun than the Earth is. In turn, it completes its orbit in about 29.5 years. Saturn's rotation speed has been a bit of a mystery. Several spacecraft have sent back different measurements, and actually the planet does rotate at a different speed at the poles than it does at the equator. This means that the exact rotation period of Saturn has been very difficult to determine, but astronomers have agreed on a time of around 10 hours and 33 minutes, and this was agreed upon via the planet's magnetic field rotation speed, because if the planet has inconsistent rotation speeds across the surface, then it's best to simply just use the magnetic field. That is complicated. That means you've got to do in situ measurements, and so Cassini did that quite nicely for us. Saturn's axial tilt is around about 27 degrees, and this means it has sort of similar-ish kind of seasonal changes to Earth. I mean, yes, it is a gas giant. It's only a little bit more tilted than Earth is, so that means it has a sort of similar seasonal cycle. Saturn is of course the second biggest planet in the solar system, as most of you may know. It has a diameter of about 116,000 kilometers, but this is an average diameter. Actually, just like Jupiter, it rotates so quickly that it sort of squashes itself, and so therefore the polar diameter is smaller than the equatorial diameter. Now, one of the strangest things about Saturn is its mass, actually. Its mass is about 95 times that of Earth's, which is not surprising given its size, but that means that despite only being slightly smaller than Jupiter, Jupiter is actually more than 3 times more massive. And so, in turn, that makes Saturn the least dense planet in the solar system by quite a long way. It is 0.68 grams per centimeter cubed, and so rather famously Saturn is less dense than water. If you had somehow a big mass of water somehow that was big enough to fit Saturn in it, Saturn would float on it, and it is the only planet in the solar system that would do that. So now let's talk about Saturn's atmosphere. Now at first sight, Saturn's atmosphere looks quite bland, and it doesn't look like there's much going on, but if you peer into more detail, like these pictures we're seeing on screen right now, you can see there is a tremendous amount of small details. It does have bands going across it, although nothing like we see on Jupiter, but they are there, and in fact Saturn does have some of the strongest wind speeds in the solar system, at over 1,800 kilometers per hour. That is fast. And the Cassini spacecraft, while it was studying Saturn from 2004 to 2017, detected lightning in Saturn's atmosphere, and just like Jupiter, it is so much more powerful than on Earth, more than 10,000 times more powerful. And what causes this lightning at the moment is a bit of a mystery, but scientists seem to think that it's actually ammonia ice crystals colliding and creating a static charge. Now, about the composition of Saturn's atmosphere, it is about 96% hydrogen and 3% helium with some more trace amounts of other gases. Saturn does actually have a little bit of methane in its atmosphere as well. We think that lightning in the Saturnian atmosphere actually transforms that bit of methane gas into clouds of soot which fall through the Saturnian atmosphere, and eventually, of course, the further you go down, the pressure becomes more and more intense. So the further you go down, the chunks of soot are under so much pressure that they transform into actual diamonds. Like you have diamonds falling through Saturn is what we think happens. And you may be asking, how does a methane gas get transformed into diamonds? Well, diamonds are pure carbon, and methane gas is carbon with 4 hydrogens attached. So you can see the carbon origin of these diamonds. Even these diamonds succumb to the enormous pressures further down, and they actually liquefy under the immense pressure, and that's just the nature of these gas giants. We do think that this happens in most gas giants that have methane in their atmospheres. Some of the weather systems that we see on Saturn are truly magnificent. The Cassini spacecraft captured this unbelievable photo of the atmosphere of Saturn. Basically what is happening is that a seasonal storm has appeared in the planet's atmosphere called a megastorm. We believe this storm is seasonal, and we think it happens once every Saturnian year, and this storm lasted for weeks and weeks and weeks. Now Saturn has huge polar storms. Now on the South Pole is this enormous hurricane that has been going on quite possibly since the planet formed. But I think what is really fascinating is what's going on at Saturn's North Pole. It is a hexagonal storm that has again quite possibly been there for billions of years, and it is a real mystery how this keeps going as a perfect hexagonal structure. No one quite knows how the hexagon stays how it is. Scientists have been able to sort of recreate a hexagonal structure by moving fluids around in circles at different speeds at certain points around the circle. That's the best we can do really, but for now it remains as a very ominous looking hexagon. It almost looks artificial, doesn't it? The center of this hexagon is again a violent storm, most likely permanent. Now, weather on Earth is powered by the heat of the sun. The sun heats the ground up, causes air to rise, and then it cools, and if there's water in it, it condenses into clouds. The clouds then rain down water. But on Saturn, it is quite literally impossible for the sun to power its weather. It's over 1 billion kilometers away from the sun. The sun is about 100 times fainter on Saturn than it is on Earth, and yet the storms on Saturn are far more powerful than on Earth. And so this means that Saturn must have an internal heat source at its center. Now, the interior of the gas giants is very unknown. It's always a mystery because, well, we can't literally go in, otherwise we'll be crushed to a pulp. But we can make guesses studying Saturn's atmosphere and the composition of its atmosphere, and what we probably think is going on is that, just like Jupiter, Saturn, towards the center, its pressure is enormous, and so the hydrogen at the center is under so much pressure that it forms this metallic liquid, and the small amounts of helium that is in Saturn's atmosphere also turns into a liquid. And what we think happens is that the molten helium falls like rain on Earth through this metallic hydrogen, and it creates an incredible amount of heat, and that heat rises up through the planet and creates these incredible storms that we see in its atmosphere. Like every gas giant in the solar system, Saturn has its own magnetic field, or magnetosphere, whatever you want to call it. It is nowhere near as powerful as Jupiter, but it's still pretty big. It's big enough to encase all of its major moons in it. In that case, it protects all of its moons from the sun's radiation, even though it's not very much this far from the sun. But this powerful magnetosphere also means Saturn experiences aurora, just like every other planet does with the magnetosphere. Now, in the video I did for Jupiter, I didn't cover the aurorae, but as you can imagine, it is unbelievably powerful, as is Saturn's. Saturn's isn't as powerful as Jupiter's, but it is still powerful, and Hubble Space Telescope has been able to easily see it. Now, I'll go through magnetic fields a bit more in future videos, but there's one thing I would like to point out about Saturn's magnetic field, which is a bit of a mystery. Saturn's magnetic poles are almost perfectly aligned with the planet's poles, and you might think that this is obvious, but actually Earth's magnetic poles are actually offset from the planet's actual poles. And this is the case with pretty much any object in the solar system that has a magnetic field, but Saturn's is perfectly aligned with its axis. Now, according to dynamo theory, A planet's axial poles being aligned with the magnetic poles should mean that the magnetic field sort of fizzles away and sort of dies, if you like. But Saturn's magnetic field is alive and well. So, how does Saturn's magnetic field survive? The answer is, we don't know. We simply do not know why Saturn's magnetic field is still going. It is completely disobeying dynamo theory. We simply don't know if there is something else that's helping Saturn's magnetic field stay, or whether it's just some completely new physics that we just don't know yet. Now, moving on away from the actual planet and onto Saturn's moons. Now, Saturn has 146 moons at the time of recording this video. This is the most of any planet in the solar system. And these range to planetary-sized bodies like Titan to small, irregular lumps of rock. And just like Jupiter's moons, they are so varied and so fascinating. I'm going to go onto these moons in other videos. We're going to make separate videos about especially Titan and Enceladus, and maybe some other videos about some other moons as well. Now, a video about Saturn would not be complete without mentioning its rings. Its rings are the most spectacular thing about the planet, and they are so magnificent. Nobody quite knew how magnificent they were until Voyager spacecraft arrived at Saturn in the early 1980s. It wasn't until the invention of the telescope that we first actually saw them. Galileo Galilei, the Italian astronomer which discovered Jupiter's 4 largest moons, observed these rings of Saturn, but he didn't quite know what they were. He literally described the planet Saturn as having ears. And of course, this is definitely not the case. But about half a century later, the Dutch astronomer Christian Huygens had an answer. He correctly surmised that Saturn had a sort of ring of debris surrounding it, and this turned out to be true. We've known that Saturn had rings for 4 centuries now, but there are some mysteries about the rings. Some things that just don't make sense. Now, every gas giant planet in the solar system has a ring system, but none are as big or as bright as Saturn's rings. And the reason is because the other ring systems are made of dark, dusty materials, and a lot of dust has fallen onto these ring particles and has made them darker and dimmer over time. But that hasn't happened with Saturn's rings. The question is why? Because the solar system is full of dust. If the rings around other planets have been darkened and dimmed by the dust in the solar system, then why haven't Saturn's? The dust is quite equally distributed around the solar system, and it should darken the rings within a few 100 million years or so. Now, when Cassini arrived at Saturn in 2004, it immediately began to study Saturn's rings. The data that Cassini beamed back left scientists with no choice but to conclude this. If the rings had been around Saturn for many billions of years since its formation, then the rings indeed should have been darkened and dimmed by the dust. So the only way the rings are so bright around Saturn is they are young. Scientists now believe that Saturn's rings formed when the dinosaurs were roaming the Earth. In fact, maybe even after the dinosaurs roamed the Earth, after the extinction event. The estimates range from around 100 million years ago to even as recent as 10 million years ago. These rings are young. Saturn has 4 distinct main rings, and they are the A ring, the B ring, the C ring, and the D ring. But there are some extra rings just outside the main ring system. They are called the F, the G, and the E rings. Now, the F ring is a tiny little sliver of a ring just outside the A ring. The G ring is a much fainter ring a bit outside the F ring. And then the E ring is even further out, which is actually one of the bluest objects in the solar system. And its source is the icy moon Enceladus, which we will go on to in a future video. And even further out, this is now about 12 million kilometers from the planet, there is this extra ring called the Phoebe ring, which is caused by the dust that's coming off Saturn's moon Phoebe. It's a small rocky moon about 200 kilometers across, and it gives off a lot of dust. Now, Cassini and Voyager, actually, discovered that surrounding the F ring around Saturn are two moons called Prometheus and Pandora, and they actually keep the F ring very neatly thin around Saturn. Prometheus is on the inside, Pandora is on the outside. And basically, by their very small gravitational influences, because they're only about 100 kilometers across, they distort the rings as they go past. If there are any ring particles falling out of this ring structure, Prometheus will accelerate them back up into the thin ring again. And if there is a particle that is gaining energy and is escaping the rings, Pandora will then slow it down and then shift it back into the F ring again. And these moons are known as shepherd moons because they keep the ring structures nice and neat, almost protecting them like a shepherd does with his sheep. And there are many more shepherd moons around Saturn. Another example is the moon Pan, which orbits in a small gap in the A ring, and basically by its very small gravitational influence it clears out this gap and it actually collects a bit of the debris from each side, and it forms like a sort of flat disc around its main body frame, and it's a very strange looking moon because of that. And so there you have it. That is almost everything you could want to know about Saturn. And now you can see that this planet is just as mysterious as it is beautiful. I would like to thank you all for watching this video. I really enjoyed talking about Saturn today. It is one of my favourite planets, and many more videos will be coming in the future about this planet because it is just beautiful. And that goes for all the planets, to be honest, but yeah, thank you all for watching. I enjoyed it and I hope you did too. Please leave a like down below if you did enjoy it. It would be greatly appreciated if you did. And I'll see you all next time for when we go out into the darkness. Goodbye.